Alright, so we are continuing with forces and Newton's laws of motion. Now, first I'm going to talk about forces. We already talked about the three laws of motion. The first law, which is the law of inertia, we have got a second law, which is force is equal to mass times acceleration. We have got the third law, which says to every action force, there is a reaction force. Now, just those laws, you are going to apply them on forces. When you're talking about forces, we have got so many different types of forces, and one of those we're going to talk about firstly is the weight force. So the weight force is just the force that pulls something down. So it is always making 90 degrees to the surface or the ground. That's a net force. So anything that has got mass has got a weight force. This is the first force that we should be able to know. And this force is given by mass multiplied by gravity. And we know gravity is a constant that is 9.8. So just anything that has got mass is going to have a weight force. The second force is the normal force. Whether we use capital N or you see someone is going to write F and then N there, just like the weight force, I can write F and then I put W. So it doesn't matter. So the normal force is a force that makes 90 degrees to any surface. So if you have got a surface like this and then you've got an object here, the normal force is going to come from the object. It is going to be pointed up like that. If you have got, for example, an incline like this and then you have got an object there, the normal force is going to be like that. It is always going to make 90 degrees to the surface. If you have got something like this and then you put an object like this, the normal force is going to go like that. It will make 90 degrees here. If you have got something like this and then something is attached there, the normal force is going to go down like that. In this case, the normal force is going to be equal to the weight force. So the normal force is the force that always makes 90 degrees to the surface. Because of this, in some cases, the normal force is going to be equal to the weight force. Like in this question here, you see you have one force that is going up, and then on this same object you're also going to have a weight force which is going down, and these two forces are supposed to balance themselves if something is not moving. So the one where something will not move is if the net force is equal to 0. When the net force is equal to 0, meaning that the acceleration of something is also equal to 0. What do we mean? When the acceleration of something is equal to 0, meaning that something is not moving. So in a case like this one, you are going to say net force. In what direction is this? This is in the y direction because we're talking about up and down. So the net force is going to be equal to the upward force. You write any upward forces, they are going to carry a positive sign. It's up to you to decide which one is going to carry a positive sign, whether the upward forces should carry a negative sign and the downward forces positive, or it's up to you. So here I'm going to take that all the upward forces are going to carry a positive sign, and we only have one upward force, that's a normal force. And then we are going to add the downward forces, but they're going to carry a negative sign. So the weight is going to carry a negative sign. Now, because this thing is not moving, going up or down, the net force, remember, according to Newton's second law of motion, is given by mass multiplied by acceleration. Because this thing is not moving up and down, that means acceleration is equal to 0. And 0 times mass is still 0, meaning that the net force here is going to be 0, and that will be equal to normal force minus weight force. Hope that is good. And so if we take this W the other side, that is going to give us weight force being equal to normal force. So in a case like this one, if you don't have any other force that is applied on an object in the y direction, then the normal force is going to be equal to the weight force. But it's not, you shouldn't master it that normal force is always equal to weight force. They are different. Okay. Another force that you should be able to know is a tension force. Now, tension force is simply the force that is found in a rope. Imagine maybe you've got, this is your block, and then you've got a rope, you are pulling it in that direction. So the force in this rope is what we call the tension. So it's really not different from these other forces we're talking about. So same, imagine I'm pulling something in this direction and then there's a force pulling it in this direction. For me to be able to find the net force is going to be equal to the force that I'm applying. In this case, it's the tension because it's the tension that is pulling this object, and then minus any force that is pulling in the other direction. So that will give you the net force. So if this thing is moving, then net force is going to be given by mass times acceleration, and that will be equal to tension minus friction. Now if this thing is not moving, meaning that the acceleration is going to be equal to 0. So this is going to be 0 is equal to tension minus friction, meaning that this friction, we take it the other side, friction is going to be equal to tension. So the only way something is not cannot move is when the force that you are applying is equal to the force that is pulling something behind, then something will not be able to move. So because of this, we should be able also to understand friction. That is another type of force. Now we're not talking about friction. Friction is simply a force that opposes motion. Now we're not talking about friction. We have got two types of friction. We've got one, we have got static friction. And this one, the symbol is small f with an s there. And then the second one we have is kinetic friction. So when you're talking about these two types of friction, depending, and this one will be small f with a k there. So static friction is friction that prevents motion. I mean, static friction is a friction that prevents something from starting to move. But kinetic friction is a friction that acts on something that is already moving to prevent it from continuing to move. For example, take you've got this box on, let's say on a table. You want to push it in this direction with a certain force. So if there is a static friction here, before it starts moving, there is a static friction acting on this object in that direction. So when you start applying a force, this object will not just start moving like that. Not until you reach a certain value that is going to overcome this static friction. That is when the box is going to start moving. But as long as you have applied a force that is smaller than a force that is of the static friction, it will not move. This explains why if you are pulling, imagine you are pushing a vehicle. If you are alone and you are pushing a vehicle, it will never move not until you apply a force that is greater than what? The static friction force. Immediately you apply a force that is greater than the static friction force will stop working. What will start working now is kinetic friction because something is now in motion. Now let's understand how these work. It's really an interesting concept to know. Let's say we have got an object here which is on the ground. This object has a mass of 5 kg. When you're working with mass in physics, you work in the SI unit, that is the kg. Now, let's say on this object, whenever you are calculating static friction has got a formula, static friction, just like kinetic friction. So static friction is given by coefficient of static friction multiplied by normal force. Please, this is mu, it's not a u. We say coefficient of static friction. Okay, multiplied by the normal force. Now, this static friction is only valid up to a certain value. It is not always, it doesn't always work. So that's why the symbol, instead of using equal sign, we're going to say static friction is less than or equal to mu s times normal force. Immediately you exceed this value, then it stops working. It is only valid for a certain value. Okay. And then you have got also kinetic friction. And kinetic friction is given by mu k times normal force. This is coefficient of kinetic friction. This is coefficient of static friction. Now, the coefficient of static friction depends on the object, and this is mostly a number between 0 and 1. So if they ask for you to calculate the coefficient of static friction or kinetic friction, you find a 10 or a 20, you should be able to doubt yourself. It's a number between 0 and 1. So this just tells you how much an object is able to resist when you are trying to push something along it, or it tells you about the roughness of an object. For example, when you have got a smooth surface, you can easily slide. Now, if you've got a rough surface, they are going to have different coefficient of kinetic friction and coefficient of static friction depending with the object. Now, let's say we have got this place where we've put this object, and on here the coefficient of static friction, let's say 0.35, and then the coefficient of kinetic friction, let's say, is 0.25. Now, let's find the static friction acting on this object and also the kinetic friction acting on this object. So the kinetic friction, starting first with the static friction, is going to be less than or equal to mu s multiplied by the normal force. And here this is going to be less than or equal to mu s, we can say that is a 0.35. The normal force, how do you find the normal force? Normal force, you look at an object. So in this case, if you look at this object, it's not moving. It's not going up or down. So the force going up, that's a normal force, should be equal to the force that is going down. Why? Because this thing is not going up or down. So that is the thing. So in this case, the normal force is going to be equal to the weight force. So we're going to say this 0.35, but how do we find the weight force? So in this case, we're saying normal force is going to be equal to weight force, and weight force we know is given by mass times gravity. So this is going to be, the mass here is 5 kg, gravity is 9.8. So this is going to give us less than or equal. If you have got a calculator, you can go on and get to punch that. So this is given me 17.15 newtons. This is the static friction force. Now let's calculate the kinetic friction. Kinetic friction is given by mu k times normal force. Mu k here is 0.25. The normal force is also mass times gravity. Mass is 5 times 9.8, and that is going to be equal to, so this is giving me 12.25 newtons. These are forces. Forces are measured in newtons. Now that we've seen this, I can now remove this so that we see what is going to be happening depending on the force that we apply on this object. Okay, so when you're talking about kinetic friction and static friction can be greater than be a number between 0 and 1, but coefficient of static friction and coefficient of kinetic friction, these are numbers between 0 and 1. Okay, you can follow that, we'll talk about it. So this is the object at this point. It's on a table. We've seen the coefficient of kinetic friction and the coefficient of static friction. Again, one thing that I always talk about is the net force. Net force, you see this symbol. This symbol means summation of forces. Net force is given by any force that you are going to apply, which we say applied force, minus any friction force. It can be kinetic or static friction. Okay. So this is an object at this point. So I'm going to put here applied force. I'm going to put static friction. I'm going to put kinetic friction. Then I'm going to put net force here. So what is going to happen is this. To this object, we are applying a force here, applied force. If I don't apply any force, then even the static friction will not be working. even the kinetic friction will not be working. In this case also the net force will not be working. Pay attention to the static friction. Static friction is the friction that is preventing this thing from starting to move. It's more like something that is pushing you when you want to move. So when I apply 5 newtons force, you look at the static friction. The 5 newtons is less than the static friction, meaning that the static friction is also going to act as a 5 newtons. Kinetic friction is not going to work. Why? Because this thing is no longer moving. So static friction will always act as the applied force as long as you are applying a force less than itself. And then to find the net force is going to be applied force minus friction force. That is going to give you 0. This thing will not be able to move. If I apply 17 newtons, look at the static friction, 17.15. This is still less than the static friction force. So even the static friction force is going to act as 17 newtons. The kinetic friction is not working. These two are going to subtract each other. The net force is going to be 0. If I apply a force that is exactly 17.15, even the static friction is going to act as 17.15. Kinetic friction is not working still, and the net force will still be 0. So 17.15 is the minimum force that I have to apply on this object if it is to work. Such questions you are going to find them. Find the minimum force that you have to apply on an object for it to start moving. All they're asking you is calculate the static friction. That's why we are saying is less than or equal to. It's the minimum. Immediately I apply this, any slight move that I'm going to take, even 17.16, it will start moving because it is greater than. So this means that if I apply 18 newtons, then static friction stops working in this case. So it will now be 0. An object has started moving because I've already extended the friction that was preventing it from moving. And what will start working is what? Is the kinetic friction. So I'm going to have 12.25 here. And so in this case, to find now the net force, the force with which this object is going to be moving, you are going to say applied force minus friction force. Now in this case, the applied force is the 18. The friction now acting is the 12.25. So it will be 18 minus 12.25. So in this case now, the net force on this object is going to be 5.75 newtons. This is the force that is going to be working with. So if you want to find what to be the acceleration of this object, you now go to Newton's second law of motion. Force is given by mass multiplied by the acceleration. So when you are talking about this force which is here, you don't talk about the applied force, not the force that you're applying, you talk about the net force. So I'm going to talk about the force that is going forward, you remove the force that is going behind, and then that answer that you get, that's the force we're going to put here. In this case it is 5.75, and this is going to be equal to the mass of this object. We saw this is a 5 kg object multiplied by the acceleration. Therefore the acceleration is going to be 5.75 divided by 5. So this object is going to be moving at an acceleration of 1.15 meters per second squared. So this is how you make these operations when it comes to friction forces.